Hi, in this video, I will be showing you problem number 7 of chapter 14, section 8. Each of these extreme value problems has a solution with both a maximum value and a minimum value. Use Lagrange multipliers to find the extreme values of the function subject to the given constraint. F of x, y, z equal to 2x plus 2y plus z. And the constraint is x square plus y square plus z square equal to 9. So the underlined words are the keywords. Maximum value, minimum value need to be found by the Lagrange multipliers and then subject to the given constraint. So function is given and the constraint is x square plus y square plus z square equal to 9. Let's first go over what we mean by Lagrange multiplier method. Explain how the method of Lagrange multipliers works in finding the extreme values of f of x, y, z subject to the constraint g of x, y, z equal to k. Method of Lagrange multipliers. To find the maximum and minimum values of f of x, y, z subject to the constraint g of x, y, z equal to k, assume that these extreme values exist and the gradient of g, del g, is not equal to 0 on the surface g of x, y, z equal to k. A. Find all values of x, y, z and lambda such that del f x, y, z equal to lambda times del g x, y, z. And g of x, y, z equal to k. Evaluate f at all points x, y, z that result in from step A. The largest of these values is the maximum value of f and the smallest is the minimum value of f. Note, the number lambda is called the Lagrange multiplier. In other words, the maximum or minimum occurs when gradient of f and gradient of g are parallel from step A. If one is a scalar multiple of the other, then the two vectors are parallel. Now let's write down the given expression f of x, y, z equal to 2x plus 2y plus z. And the constraint is x square plus y square plus z square equal to 9. We call this constraint as g of x, y, z. Now Lagrange multiplier method is what we are going to apply. So we are going to set del f equal to lambda times del g. Del f equal to lambda times del g vector is same as component form fx comma fy equal to fy fz equal to lambda times gx comma gy comma gz. So fx stands for the partial derivative with respect to x. Likewise fy and fz. G sub x stands for the partial derivative of g with respect to x. Likewise gy and gz. So if we set these two equal and write down the component form for each one of them, we get 2, 2, 1 equal to lambda times or 2 lambda x, 2 lambda y, 2 lambda z by bringing in the lambda inside the component, inside the component form. Equating the corresponding components on either side, we get three equations which are 2 lambda x equal to 2, 2 lambda y equal to 2 and 2 lambda z equal to 1. And the constraint is x square plus y square plus z square equal to 9. Then 2 lambda x equal to 2 will imply x equal to 1 over lambda. Same way, y equal to 1 over lambda and z equal to 1 over 2 lambda. Call it b. Now we'll use the constraint and substitute x, y, z into the constraint function x square plus y square plus z square equal to 9. Substituting x equal to x, y, z into the constraint x square plus y square plus z square equal to 9, we get 1 over lambda square, 1 over lambda square plus 1 over lambda the whole square plus 1 over 2 lambda the whole square equal to 9. Simplifying this, we get 9 over 4 lambda square equal to 9, or 4 lambda square equal to 1, or lambda square equal to 1/4, and taking the square root on both sides, we get lambda equal to plus or minus 1/2. Using this value of lambda, we can actually get x, y, z from step B. Substituting lambda equal to plus or minus 1/2 into b, we get two possible values for x, y, and z each. So x equal to plus or minus 2, y equal to plus or minus 2, and z equal to plus or minus 1. Now we got x, y, z. Now we are going to find out the values of f at these points and pick the highest and the lowest. Thus f has possible extreme values at two, 2, 1 and -2, -2, -1. So the maximum value is obviously at value of f with the constraint x square plus y square plus z square equal to 9 is f of 2, 2, 1, 2, 2, 1 equal to 9. Then the minimum value of f with the constraint x square plus y square equal to 9 is f of -2, -2, -1, which is equal to -9. So the maximum value of f is 9 and the minimum value of f is -9, together with the constraint x square plus y square plus z square equal to 9. Keep in mind, we are not finding the highest value of f. We are finding the highest value of f lying on the curve x square plus y square plus z square equal to 9. Hope this video helps.